Hello guys! In this video, we will be discussing about implicit differentiation. Now this is an example of an implicit function, meaning to say, this function does not define explicitly the function y with respect to x. So this is an example of an implicit function wherein we are going to employ or apply the derivative directly from this function. But before that, we know that y is equal to the f of x function. And when we say y, the derivative of y could be y prime, or this can be written as dy over dx. So y prime means that this is now the derivative of y with respect to x, that's y prime, or dy over dx, or the derivative of y with respect to x. So y prime and dy over dx are derivative symbols for y. Now from this implicit function, we are going to directly use or apply the derivative. Now, the derivative of 3x, this first term is actually using constant times a function. And since we are respecting to x, the derivative of 3x will be 3 plus. Next is we are going to get the derivative of 5y. Now the derivative of 5y is just 5 times dy over dx. And the derivative of 9 is just 0. In short, from this line, what we did is that we are going to get the derivative of every terms of the function and also the derivative of the right side. So the derivative of 3x is 3. The derivative of 5y is 5 times the derivative of y, which is dy over dx, because this is constant times a function. So copy the constant, and then the derivative of y is dy over dx, which is our agreement a while ago, that the derivative of y is dy over dx or y prime. So you can choose any of the symbol. The derivative of 9 is just 0. Now our goal is to solve for dy over dx, or for the derivative. So all we have to do is to transpose 3 to the right, transposing 3 to the right. So this will become 5 dy over dx is now equal to negative 3. Now we are going to divide both sides with 5 in order to solve for dy over dx. So if you are going to divide both sides by 5, so 5 dy over dx, okay, is now equal to negative 3. So all we have to do is to divide both sides by 5 and then cancel 5, and then we have here dy over dx is now equal to negative 3 over 5. This is now our derivative coming from an implicit function. Another example, assuming we have here a function 2xy plus y is equal to negative 2. Now here we are going to get the derivative of the left and derivative of the right. Now in the left portion of our function, we have here 2xy plus y, and the right side of our equation is negative 2. So we are going to get the derivative of the first term and the second term from the left portion. Now, the first term is 2xy. So I am going to pick 2x as a first function and y as a second function. So if this is our u and the second function is our v, then basically we are multiplying the function u and the v, so this is product rule. And if you could recall the product rule, it says that if you have u times v as a function, okay, if you have y is equal to u times v, in getting the derivative of y with respect to x, this is just u times v prime plus v times u prime, where v prime is the derivative of v function and u prime is the derivative of the u function. So we are going to make use of this formula in finding the derivative of the first term. So at this point, our u is equal to 2x and our y is equal to v. So our u here is equal to 2x and our v here is equal to y. So by following the formula, all you have to do is to copy the u, and that's 2x, because this is product rule, times the derivative of y, which is dy over dx, plus following the operation, which is addition, and then v, copy your y, times the derivative of u or the derivative of 2x, which is 2. So basically this process is a process from the product rule. And then what's the derivative of the second term? Copy the operation plus, and then the derivative of y is dy over dx. And also we are going to apply the derivative of the right side. What is the derivative of negative 2? 0. At this point, we have to solve for our dy over dx. So we have to combine all the terms bearing dy over dx and transposing the only term 2y to the right. So this is now 2x times dy over dx, copying dy over dx, and then transposing 2y to the right. So this will become negative 2y. So y times 2, that's 2y. From positive, it will become negative. The next thing to do is that we are going to do factorization. The common of the first term and the second term from the left portion of the equation is dy over dx. So we are going to factor that out. So this is now dy over dx. What's left in the first term is 2x. Copy the operation. What's left in the first term? That's 1. So if you will try to make use of distributive property, the expanded figure will be the previous left side, which is now equal to negative 2y. And so if we are going to solve for dy over dx, we are going to divide both sides with 2x plus 1. So divide both sides with 2x plus 1, and of course dividing here on the right side to maintain the equality symbol. At this point, we can now cancel that. What's left is dy over dx, which is now equal to negative 2y over 2x plus 1. This is now our derivative. Thank you for watching.